This is video 2 in the lesson in which we review the quadratic formula and then also talk about something called the discriminant, which again I think you've probably studied before. So we're first going to talk about what the discriminant is. We're going to talk about what the discriminant tells us about the nature of the roots of a quadratic, and then we're going to practice just example 1 in this video. So the discriminant, so as this says, I'm going to erase this. It says, given a quadratic equation of the form ax squared plus bx plus c equals 0, so that's the same form that we had back here when we did the quadratic formula, they're making a specification that a, b, and c all have to be elements of the real numbers. So real numbers meaning, whole numbers, fractions, decimals, square roots of positive numbers, but not square roots of negative numbers. Those would be in the complex numbers or the imaginary numbers. They're also telling us that a cannot equal 0, because if a is equal to 0, then we lose this whole first term and it's not quadratic anymore. So they want to keep it quadratic. So if you have something of that form, then there's something that's called the discriminant. And the discriminant, as this says, is the expression in the formula, in the quadratic formula, that is under the square root. And it's denoted by this letter triangle, which is called delta. And you know that from looking at slope. Slope is delta y over delta x. All right, so delta, as it says, is the expression in the formula that's under the square root. So if we go back here, the expression that's under the square root is the b squared minus 4ac. So that's the discriminant, b squared minus 4ac. Now notice there's no square root sign in that. It's just the b squared minus 4ac. So using the examples that we just did up here, we're going to talk a little bit about how the sign of the discriminant, whether it's positive, greater than 0, negative, that is less than 0, or equal to 0, tells us what kinds of solutions we're going to end up with. So the first one is case 1, if the discriminant is greater than 0. So if we go back here and look at the problems where the discriminant was greater than 0, we see number 1, the discriminant was 16, that's greater than 0. Number 2, the discriminant was 24, that's greater than 0. Now in this one the discriminant was 0, so we're not interested in that. And in this one the discriminant was negative 7, so we're not interested in that one right now either. So notice that for both of these, problems 1 and 2, where the discriminant was positive, we're taking the square root of a positive number, which is perfectly fine. In this one, it turned out this was a perfect square, and so we just got the number 4. Here, this was not a perfect square, but because it was the square root of a positive, it was a real number, and we were able to simplify it. But in both cases, notice that we ended up with, as this says, two distinct real roots. Two distinct real roots. We saw it kind of branching off and giving us two different solutions. So that's what's going to happen if the discriminant is 0, just the b squared minus 4ac, the number under the square root sign. Then we're going to say that this has two distinct real roots. And when we talk about roots, we're also talking about the solutions to that equation. Now, if the discriminant is equal to 0, then we saw that happening in this problem, number 3, where the discriminant was equal to 0. And so notice that that turned out to be, and I've erased part of this, this turned out to be, we got the same solution twice. So, and it was a real number, because it's okay to take the square root of 0, and the square root of 0 is just 0. These are real numbers, so that means we get real solutions. But it's this time one repeated real solution, or root. And I showed you down here another way of looking at it for how we can see that that solution is repeated, that it really turns up twice. And then the last one is, what if the discriminant is less than 0? So if the discriminant is less than 0, we saw that happening in problem 4. And right down here is where we saw that, and we saw that we had no real solutions. So your book for right now just says no real solutions because they haven't reviewed with you yet how to do imaginary numbers or complex numbers. So they could say that it has two actually it would be two distinct complex solutions. So complex numbers is where the imaginary numbers are showing up. So we can say that, but we can say that later. So for right now, we're just going to leave it at this, no real solutions. So in example 1, it says, without solving, determine the nature of the roots of each equation. So what they mean is don't go all the way to the end of what the solutions to the equation are. Just use the discriminant. We still need to know the values of a, b, and c. So in this one, a is 5, b is 7, c is -1. So the discriminant then, which is b squared minus 4ac, is going to be 7 squared minus 4, which is 4 times a, which is 5, times c, which is -1. So we end up with 49 plus 20, because we've got the -4 here times the -1 over here, which is 69. And so 69 is positive, it's greater than 0. So we can say, therefore, we have 2 distinct real roots or solutions. And we can see that right here. When we have the discriminant greater than 0, 2 distinct real solutions. All right, for b, first we need to get it into a regular quadratic form. Ax squared plus bx plus c is equal to 0. So I'm going to subtract the 70x from both sides. And again, we just want to look at the discriminant. So a is 25, b is -70, and c is 49. And so the discriminant, which again is, we can see up here, b squared minus 4ac. So first we want b squared, so that's -70 squared, minus 4 times a, which is 25, times c, which is 49. So this turns out to be 4,900 minus, and then this is 100 times 49, so that's also 4,900. So this problem looked terrible with those big numbers, but it turns out to be 0. So what's going on there is you would be doing a problem just like we did here, where you end up with the square root of 0, which just leads to one repeated real solution. So we can say, therefore, one repeated real solution. The last one, we could go ahead with this and say that a is 2 and b is 7/4 and c is 1/2, and then find the discriminant with those fractions. And in fact, these problems are example 7 on page 157 in your textbook. And so you can look at this and see how they did this. So in fact, your book did it this way. But it's not really necessary to do that. If all we're trying to do is determine the nature of the roots, we can also just clear out those fractions. So what I'm going to do is multiply both sides by 4. So I'm multiplying this side by 4. Why? Because that's the common denominator for those two fractions. And then multiply by 4 over here. So first I have to distribute the 4, so I end up with 8x squared plus 7x plus 2 is equal to 0. And so now my value of a is 8, and b is 7, and c is 2. I will point out that the discriminant for this one will be different from the discriminant from the original one. All right, but that's okay. They didn't ask us what is the discriminant. They just said what's the nature of the solutions. So clearing out the fractions is fine. So the discriminant then is going to be b squared, so that's 7 squared, minus 4 times a, which is, this is a, which is 8, times c, which is 2. So this becomes 49 minus 32 times 2, which is 64. So this is, let me fix this. This is 49. So this turns out to be -15. So this is just like the problem that we had back here, where the discriminant, the number under the square root sign, was negative, and so that meant we were getting into the imaginary numbers. And so we have no real solutions. So we can say, therefore, in this one, no real solutions.